What are you doing?
You'll never guess. I'm taking this dipstick out and I'm throwing it away.
We need that, you know?
Not anymore.
Alright, dipstick. Out. That's for a reason, though.
Yeah, because I'm not one of those guys that thinks it's a race car, it shouldn't have a dipstick.
I don't get that. Especially on drag and drive cars, because, like, not only is it a race car, it's also a street car. Dipstick seems very important.
You know what? That's just like, let's just take the dipstick out and make a big fat unknown. I have no idea how much oil's in my engine or what condition the oil looks like. So there are people that think that.
There's actually a lot of people, and like you might say, well, it's a safety concern. No, do something about it. Zip tie it. Do something.
Yeah, mine's zip tied. You can get locking dipsticks, but I just wrap a zip tie around it.
Yeah.
But anyway.
So with that, obviously you're not just taking it out for funsies.
Yeah. I'm going to have a way to check my oil one way or the other. But the new way is I'm going to unscrew this big cap and look down inside of a tank.
Are you telling me the time has come? The time has come.
The time has come for a dry sump.
Oh, we said, if you guys remember a couple videos, last year when we were rebuilding this or building it for the first time, we said that we weren't doing that.
Yeah, crow tastes pretty good if you put enough salt and a little bit of Tabasco sauce on it.
And that translates to more horsepower and quicker ET.
So it's not that I want to dry sump, and I'm not advocating that the entire world goes dry sump. I'm saying that at the point we're at, it's kind of necessary. So you can have some fast cars that don't require a dry sump, but when you get this fast and that much horsepower, boosted applications, it's really important.
And I think one of the things is too, to his point, you don't have to overcomplicate everything. And I think that's where a dry sump can kind of seem maybe icky, for a lack of better terms, at first, because it's like you just end up, everything seems overcomplicated for what you're doing. But we are literally at the point, we'll get into data later, where we need to do this. It was funny, even when Peterson reached out, they're like, we know that you said you don't want to, but just trust us.
Yeah, and I listened to them. We met at PRI, and I listened to their, not arguments, but their reasoning.
Yeah.
And, I agree, and I understand, and I understood this going in. I understood it when we were having issues. But I can say that the last year, the last few races we've been to, it's just become more obvious why we need it. And that's because it keeps making a little more power.
Yeah, so when we first brought the 55 out, the motor that came out of the Nova had a vacuum pump. We outgrew that for about a year. We were okay. No issues. Somewhere early last year, we started having problems at the top end, and we'll get into the actual data of this, where we were losing oil pressure at the top end, like concerning oil pressure.
Under load, not just
coast.
Not just on the return road. So on the return road, you are turning out, you'd have a big fat goose egg. Zero.
Yeah.
And about the only way you can not freak out about that is put tape over the dash.
All right, so when we first started with the 55, the motor came out of the Nova. Originally had a vacuum pump on it. We outgrew that.
Yep. That made 2,336 horsepower on the engine dyno. And it sufficed, but that doesn't make this car go mid-sixes either.
No, so then probably somewhere last year, early last year, maybe the end of the year before, started noticing that, alarming. It was like a light switch. The oil pressure just all of a sudden now at the top end, not coasting off, but under load, we would see the oil pressure go from a great 80 pounds of oil pressure to just like 20. It was scary. And
where you're making like 3,000 horsepower and you're under load and you got 20 pounds.
We have no other option. We're on race week. Like, what do? We have to keep going. So you have to start testing some stuff out.
And we pull the bearings down. I think we even did that during the race just to look at them. And surprisingly, they were still good. We never did hurt a motor because of that oil pressure, but you just don't feel comfortable.
Because at first it's like, one, why did it start? Is there something else wrong? Because at first we don't know, we just why did it start? And then two, how long can you do it? It's like, we're getting by at this moment. How long can you do it? And then early last year, I think on Sick Week last year, is when Titan Oil Pumps saw our video where we were having problems, or maybe Six Summer. They reached out and sent a different oil pump, which actually made quite a bit of improvement.
Made a lot of improvement.
It did. And so we saw our oil pressure, we were still losing oil pressure on the top end, but it was a lot better than it was.
So in a nutshell, the way that was working is she would lose oil pressure from what? About the 8th mile to the quarter mile, it would just start going down.
Yeah, somewhere in that area.
So by the time you were crossing the stripe at the quarter mile, it's alarmingly low. So the only thing that we could do to band-aid that was put more oil in the crankcase. Well, then we started having puking issues. All that windage whipping that oil up was puking the tanks full of oil, and it would get all over under the hood.
And before we had the Titan, when we had a different pump, that's where we really got this like exact precise measurement. It had like 13 quarts, no more, no less. If you had less, you had major oil pressure problems. If you had more, you had puking problems. And I'm not talking like, 13 kind of, no, it was like exact on the dot.
And if, you know what, if I didn't have a dipstick, I'd have to drain that oil and measure it, wouldn't I?
That's true. So
all you dipstick haters out there.
So we got to that point where it was like, I mean, it was frustrating, and then spent a lot of time last year cutting up tanks, and we finally got the puking part figured out.
I got that. It's really good.
It
almost hurts my feelings that I don't need that anymore.
I know. And then Titan sent the new oil pump, and that's a gearator style. Mm-hmm. It made more pressure at the top end, and we could still potentially be okay with that.
The Titan pump's bitching, but now we're at that point where I'm not afraid of the oil pressure and the bearings and all of that with the Titan pump. Mm-hmm. What I'm concerned with is this time we came back from the race and there was oil everywhere under here in the belly pan.
And that's not normal.
No. So we're building excessive crankcase pressure. And that's just the blown alcohol turbo big boost thing. And it's blowing oil out of any available crack, crevice, or seal that it can.
And apparently there is a lot of crack, crevice, and seals.
Because it was wet.
It's covered. So now it's like we're okay technically. Like we have been through a lot worse situations with oil pressure, so we're like, okay, that part's not quite as concerning. It's just everything else, which made it where now it's time to do it.
Okay, the biggie. The oil leaks we got a belly pan, we can live with it. You know, maybe the intake gasket's not sealing this time on the front of the motor. I don't know, it's worse than it's ever been. But here's the biggie. Think about 13 quarts, which is above this oil pan. That's the rods are dipping into it, and the windage that's in that motor. So that's covering the cylinder walls with oil.
I was going to say though, when did you run your fastest passes in the Ranchero or the 55?
Yeah, that's a fact. On Drag Week 2014, the last day I made one pass. It was 908. That's on a naturally aspirated motor and a gasser. Back then that was unheard of. And it's like, holy cow, this thing's doing good. We came back, put it on this lift. I went to change the oil because we were going to another race the next weekend, and it drained about half a cup of oil out.
So
it ran its best time without that windage.
Because you don't have that restriction, that windage. So that's one thing. Like this will help with horsepower a little, but then also you'll get more into the details in just a second. But also just like cleaning the cylinder walls and everything like that.
The windage, just everything, the aerated oil. So it's just we're at that point. That's what it all boils down to. So, everybody gets there eventually. If you keep spending, if you have $2 million and you spend $1 million of it, now you're a millionaire. You'll get to that point.
That's true. So long story long, the time has come. We're doing a dry sump from Peterson, but those guys have made the process of swapping over to that side a lot easier. A thank you to Titan though, because they did nothing wrong in this. It's just we have more problems now.
I will use Titan in everything except for we may end up not ever going back wet sump here.
But for any other projects, let us know. All right, you have already got some stuff installed. It looks great.
Look at that.
That actually looks like it was, it looks like it was meant to be there. I guess it kind of was.
It was meant to be there. So Peterson supplied a bracket, and it's made to go on the front old school motor mounts on a big block Chevy, or small block, I suppose. It just didn't work. So the reason being was because I've got this mid plate and everything else. But that bracket is on this pump. It's a nice bracket. You can see it around here. It's got a slot on the bottom. It's got a pivot point on the top. All I did was make another bracket to bolt on those mounts. You can see now the original top bolt is up here. This is the top bolt of the bracket, so it should be up here. I just needed to lower the bracket and the pump a little bit. So I made an adapter bracket using their swinging bracket, and it's like an inch thick billet piece of aluminum. And amazingly, look at the belt. That belt is perfect length. That's the one they sent.
I think it was meant to be, but you have all of that stuff. All right, so that all looks really good. I know that we're jumping a little bit ahead here because it looks like some stuff's already installed, but you're gonna get into some more details on the system later in the video. I'm gonna get into some data with you guys, and in the rest of the video, you're gonna see this thing being assembled, built, adapted, and upgraded.
I've actually got to pull this engine out and see where the oil leak was, the major oil leak, and fix that. So it'll probably be included in here. I've got to build a new lower part of my girdle oil pan. I've got it dropped down right now to drain as much as possible. And we're going to build a lower sump, dry sump oil pan. And then there's a lot of hoses to hook up.
Other words, there's a lot to see, so let's get started. All right, so I have 3 data logs pulled up, so that way I can show you guys the numbers and the why. So the first data log I have pulled up here, you'll see on this camera. Sorry for the awkward camera in front of me. But the first data log I have pulled up is from drag week, pass 1, day 5 of 2022. So that was... All right, so let's talk numbers and data on why we actually did that. Because the numbers, you can't, it's not just a feeling or a thought, it's actual hard, cold data. All right, so the first pass that I have pulled up is from drag week, day 5, pass 1. I, for some reason, don't have a time recorded, but it looks like it was a decent pass. So, probably 690-ish, somewhere in there. Maybe a low 7, but probably 690 something. And you can see here we start with, let's see, what kind of oil pressure do we have? So all 3 logs are going to show the same thing. We're going to have RPM, TPS, and oil pressure. So RPM is in red, TPS is in green, and oil pressure is in blue. So here you can see with the green line right here, that's our TPS. You can see that this was a full throttle pass. Right in this area is where the 0 seconds is where I let go of the trans brake. So you can see that we left the line with 85 pounds of pressure, which was pretty standard. 85 pounds of pressure, that's what we saw as a starting point for pretty much everything. And throughout the course of the run, you can see here that it did go down. So that's our blue line there. We got another extra line. Let's take that off. Ew. Okay. So you can see here that it goes down, but not alarming. Like, it goes down, it stays, 55 pounds of oil pressure. 55, it's like, oh, okay, we see that it goes down, it holds there. That's not that concerning. It's just, that makes sense. We're okay with that. Well, then we start to go a little bit faster, speed up a little bit more, make a little bit more horsepower, pulling out the back end. So the next pass that I have pulled up is from pass 4, day 3 of sick week last year, so 2024. So the order of events here is that first one, and this pass had the same oil pump. So these two are comparing apples to apples. Everything's identical. So on this one, you can see right here is where I let go of the button. This is our RPM curve here. This is our oil pressure again, and this is TPS. Let's see if I can see. This was a 689 pass. So decent. Right here, we leave the line with 75 pounds of oil pressure, a little bit lower than what the other one started with, but this was 4 passes in. So chances are I had hot lapped this thing. We had a little bit more temperature in the oil, so it's probably a little thinner. So 75 is still good. But you can see here we have a lot more instability in the oil pressure. And you can see here, which is right around 8th mile, half track, it really starts to drop off. I mean, this is a rapid drop off, and we get down to 33 pounds of oil pressure. Now, the problem there is it doesn't stop. That decline doesn't stop. So at the end, as I'm coasting off, we're at 8 pounds of oil pressure. Now, at first, 8 pounds of oil pressure coasting off was so alarming. Like, that was terrifying. But it's like, what do? You know, there's nothing we really can do. It's like quit the race or just keep pushing. Surprisingly, we've learned a lot. Big blocks can survive on a lot less oil pressure than you think. We've ran it worse than that. We're not having a problem with bearings necessarily. We're not. Our bearings look great, but it's just one of those. It's like, how long can you do it? I don't know that answer. I mean, we've done it a lot. I don't know the answer to that. But all I'm trying to say is we went a little bit faster. So we went from like a low 7, high 690. Now we're turning it up just a little bit. We're running 680, high 680s. And now all of a sudden, our oil pressure is just, I mean, it's taken a beating. It's bad. So just for comparison, we're going to go back to that first log over here where you can see the blue is gradually decreasing. And then now in our second log here, you can see the rapid decrease. So not good. Now, if you remember last year, summer, we had a lot of problems. It ended up not being total. I mean, it wasn't our oil pump necessarily. It still had those problems, but we had a lot of other problems. We had some issues with some machine work in the block that came from factory. Some stuff was just a little bit misaligned. It made our lifter bores wear, and it caused a lot of problems during sick summer. Titan oil pumps, they reached out. They have a Gearator style oil pump, and they were like, we can help you. And they did. 100%. Like, I have nothing but good things to say about Titan. I just explained them the problem. They looked at the data logs and they're like, we think ours will help with that. If this doesn't work, you know, it may be time for a dry sump, whatever. So as we kind of explained earlier, we got our Titan oil pump in and stuff looked a lot better. I can say I had a lot better peace of mind. We maintained oil pressure for a lot longer. So right there, we started with 83 pounds. This is from sick week, day 1 of this year. So pass 1, day 1, sick week this year. We had all of our oil pressure at 85 until, I don't know, 4.5 seconds into the run. So that's major improvement. And then when it did drop, it dropped not as rapid and it didn't go as low. So it was 51 pounds. So that goes back to that first pass. So we're like, okay, problem solved. We're happy. Seeing 50 pounds of oil pressure at the top end. Some people would freak out about that. I know some people have like cutoffs at that point. Based on everything that we'd seen, the way our bearings looked, we were ecstatic. Titan was ecstatic. Everything was great. And honestly, we're still happy with that. Like, I'm not mad at that oil pressure. I think that's great. But as Dad mentioned earlier, we're having problems now that isn't oil pump related. It's everything else. It's the leaks. It's the massive pressure that we're building. It's the amount of oil that we're having to keep in the car. It's just all of the other things, the horsepower that much oil is robbing, which we'll still have a lot of oil with our Peterson system here. But it's going to be, this is a 3-gallon tank, I believe, but it's not inside the engine. So it's not up in the crank. It's not robbing that horsepower. So this is going to solve problems that we have other than just oil pressure. So, a side benefit of that is we're not going to have any oil pressure problems now. There won't even be a question because whatever pressure we set it at is the pressure that it will maintain. So anyways, that's the data. That's the facts. Hopefully that paints a better picture of the why. It's not just well, we think. This is what we saw. Obviously, not every car needs this, but at some point you will. And even if it's not for these reasons, this solves a lot of other stuff. So big thank you to Peterson because I think the 55 is going to be really happy after this. So we'll follow back up with the data after we make some passes in Chicago, which is coming up soon. So, all right, that's it for the numbers. We'll check back later.
So to catch you up from where I'm at now, and I've worked on it, I gotta admit, for a couple hours today, trying to figure it out. I'm just trying to get a feel for what's going on. Our fuel pump is right here. I don't want to change that. Every hose on this thing is designed to work with this fuel pump where it's at. I don't think I'm going to have to. I think I'm going to be lucky here. I used to drive it with this homemade mandrel that went through my pulleys and my crank trigger and this 1/4-inch spacer, and that put that pulley right where it would work. The Peterson's deal, kind of cool. This is a 2-piece mandrel. So you got this flange that bolts to where mine did. It's only 3 volts, but I'm going to use the other 3, and I'm going to be able to bolt it all this together with 6 bolts, but 3 of them will drive this mandrel. The dry sump pulley is splined inside. It fits on this mandrel that bolts on here, but the mandrel only sticks into it about halfway. So you get this splined piece with it'll have a bolt that goes through and holds it all together, and it has a hex head on it, which is really going to be nice because that's going to allow me to turn the engine over, which I couldn't do before with a wrench. So it's too long right now. They send them extra long, so you have to cut it off, figure out what you want, but it's going to be all pushed back like that. Now the fuel pump belt, so the dry sump belt goes on one kind of pulley. It's I don't know if they call that a metric. I think that's a metric, 8mm metric. It's like a blower belt, like the blower belts that we run. It's round toothed, and then the fuel pump's just an old square tooth belt, which we've always run. But it actually stays. I didn't even really adjust anything. That's where it was. And then this new pulley that Peterson set me up with, they asked me what size I was running, how many teeth were on it. They set me up with that. So that's going to go on there. This will cut off, tighten up, and I'll have 2 different belts on the same mandrel. And then the pump is going to mount here. So let me get the pump, and I'll show you how we're going to do that. I want to show you down inside of this pump. Look at this. This is just too cool. Talk about precision. So that's, like I say, that's like a mini screw blower or high helix blower. I can't really tell if it's a male and a female. I think it's just like a high helix, but each one of those sections you might be able to see. Let's turn it up this way. So right here, right inside, that's a cavity. You can see the other rotor down in there. I'll turn it here. See that both rotors moving. So all 4 of these sections are connected together through a passage at the top. So they all do the same thing. It's sucking in here. Each one of them sucking its own oil out of a section of the motor, but it's blowing into this common rail, and you choose one place for it to go out. Well, it can be up here. This is where they had it. I decided I'd move it here. That didn't really work out, so I'm moving it back here. So all of those are connected together. You just cap the one that you're not using, and I'm going to put it up on the engine and see how that works. I'm actually using one of the bolt holes that for this bracket. I'm just moving it down one. All right, I'm starting the new lower oil pan. This is the one that I just took off, and it works fine for what it is, but instead of cutting it up and making it into a dry sump pan, I'm going to start a new one. And I'm the kind of guy that I stock quite a bit of stuff, but I use a lot of materials up, and then I may not get it restocked for a good while. So I don't have what I need. I don't have this rail material. Let me zoom the camera out. I don't have the parts for the sides and around here. That's what I've got to make first. When I made this original pan, I did what I'm doing now. I used a 1/2 inch by 1 1/4, I believe, to make the surround, and I welded it together. So my theory is, most people would say, why would you do that? Get a plate, draw it on CAD, take it somewhere, and they can laser it or water jet all the holes and cut it out of a plate, because a plate's expensive. A friggin' plate of material over 2 foot long and 1 foot wide, 1/2 inch thick, and then you cut the whole center out of it. Why? When I can just weld 4 little 1 1/4 welds and make basically the same thing out of 4 pieces. So that's what I'm doing. Unfortunately, I don't have the 1¼ inch, but I have some 4-inch, and I've got a really big bandsaw that cuts it like butter. So I just cut one piece out of it. I'm getting ready to cut the other one. I can get 3 out of here. And so 1, 2, and then the third one will make the short pieces. So I'm gonna cut it, and it took honestly, I don't know, a minute, maybe a minute to make that cut with the blade and the saw that I have. And I'm gonna put it in the mill, and I'm just gonna face it off, and I'll take you along with that. But then I'm gonna weld all 4 pieces, set it on there, transfer the holes from this one to the new one, and then I can bend the sheet metal up, no big deal. So there we have it, 3 pieces, and one will make the 2 end pieces plus a little bit left, and it honestly took a minute a cut. But now I'm going to put them in the mill, stack them together, and I'm just going to face them. We'll see how long that takes. It takes longer to put the vise in the mill than it does to make the cut. But all that, and not a single cutoff wheel was harmed in the process. I cut 2 end pieces, the width of the pan. And what I'm going to do is clamp those on, and then I'll measure between them and cut the side pieces. And the reason I'm doing it the way I'm doing is because I can weld over here where it's not close to any bolt holes. If I made the side pieces longer, which I had the material cut there, but if I did that, I would have been welding close to a bolt hole, like within a 1/4 inch, and I didn't want to be that close. Okay, let's see what we have here. 22 1/8. 22 1/8. So I'm going to cut my 2 end pieces, 22 1/8. Then I'm going to grind a taper in them. So they've got some, not welding just on top, I'm filling the gap, and I'll weld these things together while they're clamped onto this piece. So there's the 4 pieces clamped on. I beveled them, just threw a big nasty weld on them just to build it up above the surface of the rail. Next I'll turn it over and I'm going to transfer the holes with a transfer punch through each one of them, and then I'll drill them and weld the other side of those cracks and bolt it on the oil pan out there. I can start bending the sheet metal part of it. Okay, there we have a finished rail of the oil pan. Got the notches cut out just like the other one had, all the holes drilled and chamfered, the welds ground down and ready for test fitting on the pan on the car, the girdle part, and then I can start planning my sheet metal. So let's go see if it fits the car. Okay, there it is. Fits perfect. Notch is nice. That's smooth down the side. Flat across the front like it's supposed to be. Perfect down this side. Even though the oil filter is not going to be there, I still wanted the notch, and it'll have a adapter for an external oil filter. Same deal across the back. So the next step is to design the pan and bend it, and I'll do that while the flange is up here. So after careful consideration, I'm going to do something very much like this, except I'm going to step a channel 3 inches wide here and then taper it back up. I'll show you what I mean over here in just a second. But I'm going to build it in 2 pieces like this. I'm going to put a seam here. I was going to bend it, but then it occurred to me I'm going to have a step, so I'm going to actually have to weld this thing together. It'll be multiple pieces, but I'm going to keep that same contour, and the reason is this fits my belly pan. I don't remember exactly. There's space somewhere, maybe up at the front. I don't remember, but I'm going to do it just like that to make it fit the same. I'm going to use this, which is 1/8 inch plate. And the reason I'm going to use 1/8 inch is because when we burned a hole in a piston one time, that crankcase pressure just blew into the crankcase so strong, it bowed the bottom of the pan and it busted this weld. That's why it's so janky looking, because the pan was bellied and it split that seam, even though it was welded inside and outside, and it dumped all that oil in the belly pan, which luckily we had. So I'm going to do it something like this. I use my table a lot. See if I can get in the light just right. It's going to come down 4 inches, come over 3, come up 2, angle up to 1.5. That'll be the profile of this thing. And then my fittings will weld in here. I'll take a tube across to suck off of the wall. The crankcase is going to sling the oil this direction. The tubes are going to be sucking right here. And that will be ramped so it doesn't just lay on top of that. So I'm going to do it in those 2 pieces, and I think I'm getting ready to lay that out and cut it and bend it. It's not show quality, I don't care. It's function. We treat these things very bad. They just can't be beautiful all the time, so I'm not going to worry about that. But we're going to make it like this pan, and I'm almost tempted to put this pan back up there and check my belly pan fit, because there was some space somewhere. All right, so you saw me, I don't know if you didn't see me bending it, but you saw me marking it and figuring out my shape. So there's that profile that I drew on my saw. This is slanted down slightly. As the crankshaft spins clockwise, it'll be swinging the oil against this wall and it'll gather down here. Remember, there's not going to be much oil in here because there's going to be 4 suction tubes welded in here that are going to keep it sucked out. So there'll be one at each set of rods is what I've got figured now. So there'll be I think I've got to put a filter on here. I don't have those yet. I'm hoping it's just a -12 that'll screw on here, and then this fitting will go onto that. Whatever, we'll either have 90 degrees fittings here or 45s coming out, and they'll go to these lines right here. So all the lines will be, up above the bottom of the pan, so the belly pan will still fit under here, but this notch over here is where the fittings will all go. So I'll probably put some kind of a screen in here. I don't know why exactly, but that's what everybody does. All the ones that I see, the factory made ones, maybe just to keep the oil from windage from picking it back up. But I'm getting ready to do the front part now. I came back here 10 inches and I'm going to slant this up just like the other pan was. It'll have the same contour, so the belly pan that I've already got will fit back on here. And I've just taken this big notch out of it is basically what it amounts to. So it's going to make it pretty nice. It's going to keep that oil separated from that crankshaft big time. I'm going to go back there and take this off and go back and cut that angle on that piece that I've already got bent. I just got to cut the angle to come up here. So let's do that. Okay, so I got this part tacked on. You saw that out there. Came back and cut this piece, which I bent it just square like this one, just shorter. And then I just now fixed the angles that'll match up here pretty good. So I'm gonna go back and tack this piece on. So basically it looks like that pan, the profile, so it'll fit in the belly pan the same way. It'll just have this big notch out of this side of it that this one doesn't have. This is where all our hoses are gonna attach. So that's kind of it. Kind of happy with that. I thought I had it made. The oil pan's coming out really good. The pump was hanging so nice. Everything was so grand until I realized that once I screwed the big -12 fittings onto my pump, that they were going to hang too low. I thought I had one here, but I don't. So the -12 is such a big fitting, it makes such a swoop that it was going to get in the way of the belly pan. So I've had to redesign and re-engineer and move a bunch of stuff. Our line lock solenoid was on the back side of this mid plate, and I've had to take it off. I'm going to have to relocate it. I've got to change. This is the line for the fire system. I got to move it. I've got to move the brake lines, and I've got to raise this pump up as much as possible. And there's just not much room here for that big pump to swing to loosen and tighten a belt. So I got worried that the belt was going to be too long. Anytime you raise up like that, you're moving closer to the crankshaft center line, but it actually worked perfect, and I'm glad. So that takes one variable out. So this is the way the bracket was. I just moved the upper hole to the lower hole, made this almost 1 inch bracket, and it made that pump swing. Actually, I put that on backwards. Let me take that off and turn it around the way it's supposed to be. So everything works so good. It's just that the pump was hanging too low. So what I'm doing now is I've made a cardboard pattern, poster board pattern. This bracket will neither one of these will be used. Let me get my poster board here. I'm going to make this a combination bracket here anyway. And I want to get it right the first time because I don't like wasting aluminum. So now this will be incorporated into that. This bracket's going to be shaped something like this. It'll be one big chunk, and my slot will be here. So you can see there's not much room for things to move. That's where it'll be when the belt is tight, and when the belt's loose, it'll be there. So there's just barely any movement, but it actually works. The belt, gets tight and gets just loose enough I can take it off of the pulleys. So I'm getting ready to make this combo bracket. This will become one bracket. I just cut a piece of aluminum. Here we go, right here. Cut a big 1-inch thick piece, laid this cardboard on, center punched my holes, and that'll all be cut into one shape. I'm actually going to contour it just a little bit different because that piece doesn't need to stick up. So I'm going to drill these holes, cut this thing out, and put it up there, and hopefully it works the first time. That's what you call contour bandsawing. Most of those shapes are pretty accurate. I could be a little bit closer right there, but I'll get that with a grinder. That's what they make grinders for. there you go. That's my CAD designed and CAD manufactured. You're probably used to CAD designing, computer aided designing. So this is also CAD manufactured, but it's cardboard aided design. So instead of a computer, this is how I make most of my stuff. But look, it looks nice. I don't have a problem with that. I could finish it fancier and make it better, but I'm not going to, because I want to get it on the car. So this is what I worked with, and this is what I ended up with. I almost thought there for a minute that I made something backwards, but I didn't. So, you know, when you put that all together, you end up with the same thing. I straightened some lines out, but that's a pretty nice bracket. So I'm gonna put this on here. Let's go see if it actually works in the car. I drilled and tapped those 5/16 just like the one from Peterson. Man, that looks nice. I'm happy with that. It better works, all I can say. I don't want to have to do it again. And it's not that it took that much time. You guys witnessed it. Just a few minutes on the bandsaw, a little bit of grinder work. You didn't see the milling machine, but that was, I just took that notch out of there, one, to lighten it up a little, but mainly because it's right pretty close to my fuel pump hose. And I wanted it to have a little bit more clearance. Put that on there. I think these bolts are different sizes, lengths. Let's see, there it is. I thought for a minute that my hole didn't line up, but it does. Now if the belt will tighten up, that's the biggie. Let me find my socket. All right, belt's on. I can get the belt off, obviously. There we go. So it does swing out far enough. It looks like it's gonna work. Oh, bada bing, bada boom. All right, so I don't know how much that actually moved it up, but it did. And here's the reason, because those were, you know, obviously hanging in the pan. But now I've got them, instead of pointing straight down, they were like that. And the 90-degree fittings I would have had to have on were down here. So that was going to be a big problem. Now I can use 45s. And I can run back here. And I'll go into the oil. Actually, there's going to be filters out here. I'm not sure how long they are, but they'll probably go back like that and turn into 90s and go into this pan. So now, I think that'll miss my belly pan. So that's the best I can do anyway. If it hits the belly pan is going to be the next victim of the bandsaw or cut off. So I'm getting ready to weld this thing up. That's a lot of welding. And it's aluminum, and it tends to turn into a rocking chair rail. So what I did was, this is an old fixture that I made many years ago when I made my Willys Hemi oil pan. I made it out of aluminum, actually. Actually, come to think of it, it wasn't a Willys because it's got a girdle on it. I made an oil pan for the 33 Highboy Willys that Denny Terzitz ended up with, the black Highboy, and I made an aluminum pan for it. I had all the patterns and I bolted it to this 3/8 thick steel plate so it wouldn't warp. Well, I turned it over and I drilled and tapped 3 bolts on each side. So as I'm welding this, the steel will absorb some of the heat. That's not the main reason for it, but it's just gonna keep it from doing this, because as I weld this seam, I've been there before, it will warp that pan up big time. So now it's forced to stay down. So that's my next step. I've cleaned it. It's been acid cleaned, and it's ready to run big long beads down through here and across. So let's do that. So the bottom is pretty much done until I get 4 suction filters. Then I can put my scavenge weld bungs on the oil pan. So the oil pan's welded and it's installed right now just to keep the oil from dripping on the floor. But those are being shipped from Peterson, as well as a big filter that's going to go up here between the tank and the pump. So I'm held up with that, and Red Horse is sending all the hoses and fittings, and it's a bunch. That part I don't like. But I was just thinking, I'm going to get rid of a lot of hoses. There's going to be a lot of this stuff that's not necessary anymore. So it's a little bit of a balancing act. I'll have more hoses, but most of those are going to be under the car. You won't see them. So up top, it'll be pretty good. So this is where I'm at right now. I've got to fit this big dry sump tank. You can see it over there in the chair. That's 9-inch in diameter. You can get a 7-inch, I guess, but it's smaller capacity. That's a 3-gallon tank, and the 7-inch ones that I've seen are 1.5 gallons, and that's not good for that big motor and driving. That's only 6 quarts of oil. I'm not doing that. So they actually thought we should have a 4-gallon tank, but they're okay with 3. But that 9-inch tank is a pretty big piece to fit in a car that's already crowded. What I'm going to do, it's actually going to work out pretty good. I'm going to cut this. I drew a 10-inch diameter circle right here, and I'm going to cut it straight across. So I'm going to lose this section of this tank. I've reworked my tank so many times. It used to be 1 tank, and now it's 3. And then I'm getting ready to put a block plate in there, and it's actually going to be complicated. You'll see when I get it out of here. But that dry sump tank is going to sit right here. So I'm going to put a bigger lid on it. I'm going to put the same lid that Holly uses on top of that. That's got a small, I don't know, 1.5 or 1.75 hole. And I really like the idea of having a 3-inch hole. So we've got one of these ordered. I'm going to machine the ring off of it and lose the bolt holes. I'm going to weld the ring onto that tank. And then I've got a nice 3-inch opening that I can look down in it, pour oil in it, just check the level. This is going to be nice. That'll actually set like flush to the top right here. So when I get this chunk cut out here, I've got it figured that tank will come right up to the top. I'll be able to just open that up and check the oil level. I'm really looking forward to it. That part's going to be nice. So the biggest drawback of this dry sump thing is just having to do it. I got to rebuild so much stuff. But it's going to be nice. It's evolution, and that's part of going faster. You just have to keep working on these things. They're never finished. So I just got this tank loosened up, and I thought, I haven't recorded anything this morning. Most of my morning has been, I pulled the plugs. The engine does have a water leak. That was an issue on sick week, and we used some sealer, some radiator sealer. Man, that stuff seems very corrosive, but it stopped the leak. But I can see where it's leaking. It's on the driver's side head between the block and the head. I didn't retorque these head gaskets. But I don't know why it's leaking. I got to pull the heads. I'm gonna take the engine out, pull it apart. Not the rotating assembly, but the heads and the pan. I'm gonna seal everything up, and the gaskets are old enough now. I'll reuse them, and I'll, when I put them back on, and torque them again with new silicone around all those openings. Hopefully that'll take care of that. I did look in the cylinder bores with my new fancy triple throwdown. I think I'll show you this. I'm just giving you a tech tip here. Alex got this for me for Christmas because I've been seeing them and I really wanted one, and man, is it nice. I just looked in all the bores, and the plugs look so good, and the bores look so good. The pistons look so good and clean. Look at this. Everybody's got a bore scope, right? You look at you stick it in the hole, and basically you see one side. That's all a bore scope does. If you force it in, you might get it to bend down, and you're looking at still one side. You can't see the valves. But look at this thing. Watch this end. Well, here, let me twist it. Check that out. Man, that thing, that's the coolest thing since sliced bread. And the quality of the picture is just outstanding. So I get to really, and I'm not selling these things, I'm just showing you in case you want to do something. If you hold down, you get a side view. This turn is the tip has got cameras in both sides, and if you hold it down again, you get a split screen, so you get the down and the side view. So you can pretty much check out the valves, you can check out the cylinder, the pistons, and then you can take pictures. You just push a button and take pictures. You can Bluetooth it to your phone. Hey ho, neighbor. So you saw me cutting the tank up. Plasma torch, cut off wheel, air saw, belt sander, 3-inch sander. I even think I used a 6-inch sander on it, but it's done. Let me show you this. So I've got it. You can get down and look right here. If you get right on top, it all lines up pretty good. So this is my fuel tank section. This was the puke tank section, as is that over there. So what I've got to do, instead of making one plate to cover that, I got to make 2 plates. This one's going to weld here. I'm going to have to manipulate it as I tack it, but that'll weld there. And then I'm going to weld it here so it's good and sealed. I want this tank sealed. And then I'll make another plate to cover this. So you'll see a weld down here when I'm finished, which I don't like, but it's part of it. That will be the opening for the big oil tank. So coming out good. I got it all cleaned out inside. The plasma torch made a mess in there, of course, but I scrubbed it with Scotch-Brite and some Zep, my favorite cleaner, and it's really clean. So I scubbed the outside because it had that, you still see some of it here, the stop leak that I put in it on sick week, and I've got to do the outside better, but I'm gonna wait till I get the hole filled in. So let's go weld this patch. Okay, so that first panel's welded in, leak checked. I had a couple leaks in the corner here, but I filled it up, watched it multiple times. It doesn't leak now. It don't look great, and I'm not that worried about it. My tank looks so butchered anymore. I made it look good when I first built it, and it's split the seam a couple times on these drag weeks and race weeks, and I've had to repair it, so I'm not that worried about it. The repairs don't ever really look that bad. All right, so I put the tank back in just to test fit everything. The oil tank is going to look good. It's going to clear. It's going to fit. Everything's going to be groovy there. But I've got to mount it. And this is where the old profitometer goes backwards, like in a hurry. Spins backward. So there was 2 possibilities that Peterson could have sent me. This bracket, which mounts to something like that, and a bracket that has a hole for 1 inch, I assume 1 5/8 tube, maybe 1.5 inches. But that one would have been perfect. But they didn't know, I didn't know, had no idea how this was going to mount. I could do something like this. I could put these straps around here. I could put a plate across here and weld it to a tube that goes down, and it's going to weld to my frame. But that's kind of ugly. I just can't bring myself to do it. Even though I'm in a hurry and I want to get this done, and I'm not willing to wait the several days it would take to get the brackets from Peterson, I'm going to modify these. I'm going to cut the ears off of them. I've got a couple pieces of aluminum back here. I'm going to bore a hole in my lathe, and I'm just going to weld it together. That might sound ugly, but it'll look okay. It won't look as nice as a factory made billet bracket, but it'll look fine, and it'll do the job just like what they have. And I'm gonna get this tank. I think I'm gonna make a bung, so to speak, to weld on the chassis there, and then this 1.5 or 1 5/8 tube, whichever I decide to do, will slip down in it, and I can put it on with a quick pin. Go ahead and kill it.
Okay.
So I'm gonna make that tube slide down in a receiver or a bung on the chassis, and I think I'll use a quick release pin. That way, if I need to in a hurry, I can just pull the hoses, pull that pin, and slide the thing up with the brackets on the tank and the tube still in place. I just set it down in, put the quick pin, and it'll be mounted. So I've still got to do that, and then I've got to figure out the hose routing. That's one I'm not looking forward to, because it's going to look like one of these drawers full of wire here. I'm afraid there's going to be so many hoses on this thing that it's going to be ugly, but I'm going to do my best to take them underneath and try to keep them out of sight just as best I can and clean it up. Okay, so this was going to be one episode. It never works out like that for me. It was just so much fabrication and so much stuff that I've got to make it 2 episodes. But that's okay, because Alex and Meg and myself are going to be gone next week, and I'm not going to have anything new. So it was either turn this into 2 episodes or cut a lot out and not have an episode next week while we're gone. So you're going to get 2 episodes of this, and I'm not going to show you what I'm leaning against, because it turned out pretty darn nice. I'm really pleased with it. It's one of those things that I thought at first that I don't even want to see that tank there, or any tank. It wasn't anything to do with Peterson. It's just I just didn't want another thing that looks like a race car on our car. But I like it. It looks good. I'm excited about it. It turned out well, and you'll just have to wait till next week to see. But thanks for watching this one. Thanks for watching next week, because I think you're going to want to come back, see what the rest of the fabrication is. I'm pretty pleased with what I did, and I'm gonna spill the beans here. Alex and Meg and myself are going to Sweden for a week. We're gonna be going to, I guess it's kind of like Sweden SEMA. We're gonna make an appearance over there, hang out, maybe do something else too. We got a little bit of a surprise coming up. I hope everything works out, and we get to do something really fun this year. So we'll let you know more about that, but we'll have an episode about that. Alex will definitely have an episode about that. I might be able to sneak something in myself. So thank you for everyone who went and bought a shirt. And Mika thanks you because she sold some shirts. Mika. She hears a jet. She thinks that it's UPS. Mika, is that UPS? Listen, is that UPS? Are you gonna buy it? Our UPS guy eats her food, or at least she thinks he does. Every time he comes in, she runs over and starts eating her food. She loves him, but she loves to bark at him. Everybody that comes is UPS. So anyway, Jet's gone. She's giving it up. She's gonna retire for the night. She sounds like a crocodile when she growls. She's pretty funny. So once again, thanks guys for watching. I appreciate all the support. Don't forget to subscribe, like, do all that cool stuff. Thumbs up, because it helps. It really does. I'm trying to build the viewer base, and it's going very well. And I've got a really big project coming up that you know about it, a little bit about it. You've seen the engine, and I can't wait to tell you what that is. That's coming after we get back from Sweden, because I'll have all the parts here and I'll be ready to start on it, and it's my favorite project. So hang around, because it's gonna get cool. Thanks again. See you next time.